9.1 waves in 2 dimensions. So as you see, this is the wave. We can show the direction of the movement of the waves by the ray in this direction. And this line here is gonna give you the crest or maximum and minimum. Here, transfer waves a periodic disturbance where particles in a medium oscillate at right angle to the direction in which the wave traveled. So basically, if you have a rope and you make a wave on it, this bumps is moving in this direction, but the particle oscillating up and down, right? Is oscillating up and down, and the wave energy move forward. The angle between the oscillation of the particles and the wave is 90 degrees. That's why we call it transverse waves. Wavefront, the leading edge of the continuous crest or throw. So here is the edge of the crest is maximum, right? Throw is maximum. And wave ray, the straight line drawn perpendicular to the wavefront indicate the direction of transmission. So here is the ray. It's saying that this is expanding going forward. Knowing that the velocity of the wave is equal to frequency multiplied by the wavelength, and in the same medium, the velocity will not change, but in 2 different medium, the velocity in one medium and another medium will be changed, but the frequency will stay the same. The reason is that the frequency is just depends on the source. So here is V1, if you divide these two, V1 over V2 is equal to F1 lambda 1, F2 lambda 2. You can cancel F1 and F2, you get this equation. Okay, just noted that the velocity, V1 is velocity in first medium, V2 velocity in second medium, lambda 1 is the wavelength in the first medium, lambda 2 is the wavelength in the second medium. A water wave has a wavelength of 2 centimeters in a deep section of the tank, 1 centimeter in the shallow section. If the speed of the wave shallow water is 12 centimeters per second, what is the speed of the deep water? So here we have lambda 1, lambda 2. We have V2 and just we want to find rearrange for V1. So just write this equation, rearrange it for V1 and just put the numbers, you'll get it. Practice, you can do question number 1. Reflection from a straight barrier. So the incidence wave come and the reflection, it will be reflected, right? If they encounter a barrier. So here, a wave coming and will be reflected. That's this raises the direction of the ray movement. We have an incident angle. The incident angle is the ray incoming ray, incident ray, making with a normal. Normal is a perpendicular to the surface. And the reflected angle is the angle that the reflected wave ray will make with the normal. So it's going to be theta I incident, theta R, angle of reflected wave. Okay. So here the relationship is sine of theta of incident divided by sine of theta of reflection is equal to lambda 1, lambda 2. The lambda 1 over lambda 2 is the wavelength. Is the lambda 1 over lambda 2 is the constant value. We call it n. So just here. N is the ratio between the incident, the sine of the incident angle, and our reflected angle. Here, we call it absolute index of refraction. The index of refraction is the light passing from air or a vacuum into a substance. So, okay. So N1 sine theta 1 is equal to N2 sine theta 1. If this is general rule, if The N1 is in this index of refraction in first medium, and 2 is the index of refraction in second medium. Sine theta 1 is the angle 1 in the first medium and angle that the ring makes in a second medium. Oh, this is a general one. Sine theta 1 over sine theta 2 is V1 over V2 is equal to lambda 1 over lambda 2 is equal to N2 over N1. A 5 hertz water rate traveling 31 centimeter per second. So this is velocity, this is frequency in deep water, inter shallow water, so in a different region. The angle between incident wave front in deep water and the boundary between the deep and shallow water is 50 degrees. The speed of the wave in shallow water is 20 centimeter. Find the angle of refraction in the shallow water, the wavelength in shallow water. So in a deep water, in the deep water is 50, right? So if we want to find the angle of refraction, you knowing that sine theta 1 divided by sine theta 2 is V1 over V2. You have the velocity in two mediums. You have V1 and V2. You have angle in the first medium, so sine 50. So we just rearrange it. Theta is equal to sine inverse of whatever number you get there, which is 42 degrees. And knowing the lambda is equal to velocity over frequency, since we know the frequency will not change in medium, right? It's just 5 hertz. So we have a velocity in second medium. So we have a frequency, which is the same. And you just find the wavelength in the second medium. For a light ray traveling from glass into water, find the angle of refraction in water if the angle incident in glass is 30. So incident angle is 30. Traveling from glass to water. So here is glass, here is water. This is coming because it is more dense. Dense is getting closer. Sorry, it is less dense, so it's getting away. It's not gonna cut. It's just this ray getting away from the normal. And now this is theta incident. Is theta refracted. Sine theta 1 over sine theta 2. So we have sine theta 1, which is 30. The one that theta in the water we don't have. N2 is 1.33 in water, just you can find it from table, and in glass is 1.5. Rearrange it for sine W. Here sine W is 34. As you see that the angle is more than that, so that's why it's going from less dense medium to the less dense. They're right getting away from normal. And B said the speed of light in water. Knowing that V1 over V2 is equal to N2 over N1, we know the speed of the light in vacuum in air is this. Also, if we know N for the vacuum or air is 1. So we have V1 and N1. N2 we know is in a glass, is 1.33, and we want to find the speed of that in glass. Just rearrange it for V2, then we find it. Sorry, in water. In water is N. You want to find speed in water. Water is 1.33, just put it there, you'll get it. But to practice, you can do question number 4. Partial refraction, partial reflection, partial refraction. Total internal reflection. The reflection of light in an optically denser medium, it occurs when an angle of incident in denser medium is greater than a critical angle. Normally, this is the ray coming from water into the air, from dense to the less dense. this is incoming angle. Some of that will be passed through the medium. Some of that will be reflected in the medium. This angle, the reflected of that is equal to that. But if you increase this incident angle to a specific angle, then this ray that you have passed through, it will be reflected at the edge. And if this theta getting a little bit greater than this critical angle, you just have total refraction, total internal reflection you have. So here you have a reflection and refraction. Here you have a critical angle. That's why it is refracted, and this one is just at the edge of the medium to medium. And this one, the theta I here is greater than theta C. That's why you have total internal reflection.